Hey there, you welcome to the rubber industry tech talk. Today I will be presenting new launch from Alpha Technologies, that is the premier RPA plus sub-zero technology. So my name is Dilip Dhupia. I am application specialist in Alpha Technologies for last 5 years, and I am having experience of 25 years in total. With the help of my team, uh, I could be able to attain good knowledge on the shop floor processing of the rubber compound and re- research and development with the product industrialization function. So the content of my presentation is, first of all, we will discuss about the Alpha Technologies overview as a company, what is Alpha Technologies, then the definition of continual improvement. After that, we will move to the RPA sub-zero technology. Then why this technology needs a development with RPA. Then we will go through what were the focus of our development and how the sub-zero technology works. Then followed by the technical specification of sub-zero technology. Then we will discuss something on the PDM, that is Precision Dynamic Modulus technology, which we uh, developed in the Sub-Zero. And after and in the last, we will have data comparison of RPA with the DMA, so that it will be uh, helpful for the rubber industry to understand how it correlates with the DMA and how it can replace the DMA. So let us start our journey with the Alpha Technologies background. Alpha Technologies is basically a leader in applying rheology science to the testing that makes a difference in the rubber and polymer world. And Alpha is dedicated to the development of instrument in the field of rubber testing, such that it has helped the industry to grow big. For example, when the first ASTM for rheometric properties was launched, it was based on the Monsanto, and now it is known as Alpha Technologies company. And the launch has revolutionized the quality control and the quality of the rubber product. So the presence of Alpha Technologies is there across the globe. We have 150 plus global direct associates, then 50 plus field service technicians, then followed by 25 plus customer and technical support, and we have 7 degree application engineers. I am one of them, and our calibration certificate, and our calibration services are being ISO 17025 certified, and across the globe we are having more than 18,000 equipment based installations, and with that customer base across the globe, we are number one in the world, I can say. So there is a lot riding on our testing. As you see, we are taking care of our customers, then their customer, and the actual user who is using the rubber product, their safety. So our data is being mm, used to produce reliable rubber product, such that our customers, the actual user, they are safe when they use a rubber compound. So we are trusted by all the major players in the rubber industry, but not limited to the list, that is Bridgestone, Goodyear, Michelin, Apollo Tire, Yokohama, then Pirelli, Continental, MRF, Sumitomo, C8. And I think it is appropriate to start any say discussion on the process improvement and quality control with a quote from W. Edwards Deming that equality comes not from inspection but from improvement of the production process. So this is this quote is very close to the heart of any quality control person at the shop floor, since it indicates that building a better gauge to stop a a bad product going to customer is not important. It is say basically they develop your say process and the instrument in such a way that the bad product is not produced. So now, so let us discuss. So let us start our discussion on the RPA sub-zero technology, in which RPA is being equipped with the facility of going to the temperature as low as negative 25 degrees centigrade. And you can see the RPA continual development has been about the variance reduction. You see, around 30 years back, we launched Series 2000. That is very well known in the rubber industry. Is the RPA 2000 that was really reliable and robust first generation technology. Then followed by we launched Premier RPA, in which we improved the dies and seals, and we improved the sampling rate, and the architecture of the software has been say developed in the form of the flexible architecture, and we standardized the at that point of time of the technology, and we have and we incorporated the enhanced LAOS. LAOS means large amplitude oscillatory shear. Then in the third generation of the Premier RPA Plus, we just incorporated uh, the technology to compensate for the sample shrinkage when one reduces the temperature from the curing temperature, since the RPA is being designed to perform the test on the uncured sample. Then then you cure the sample in the die. After that, just bring the temperature to the lower temperature, means above room temperature. Then just perform the dynamic testing at different temperature. Okay, so in that case, sample shrinks. Then whatever shrinkage was there in the Series 2000 and the Premier RPA, we were not able to measure that, but in the Premier RPA Plus, we are now able to say measure the extent of shrinkage of the rubber, and we are using the actual sample thickness for modulus calculation. So again, variance reduction is there. Now at the present launch is the Premier Sub-Zero, which is aimed to replace the cumbersome DMA and improve repeatability of post-cure sub-ambient test over DMA. And in the Sub-Zero, one can test up to negative to 25-degree centigrade. So the need of a development of sub-zero technology is we wish to give a testing solution for shop floor rubber compound to fulfill the stringent tire labeling requirement. You see, nowadays um, around the globe, most of the countries, they are imposing the tire labeling requirement, in which Europe was the first to implement the tire labeling, and all the tire manufacturer who are supplying the tire to Europe, they are doing the tire labeling in terms of the traction and the rolling resistance. And our and the second need is to reduce cycle time to submit test tire to OEM, since in order to develop a trade rubber compound and then to submit a test tire to OEM, in between that it requires so many testing, so many processing, say namely mixing, then sample molding, then testing in DMA. then doing the processing in shop floor, and then submitting a test tire to OEM. So with the help of RPA in sub-zero, we are being able to reduce the test time after mixing of the rubber compound. That the test time is hardly 25 minutes, while if you go for the DMA testing, it takes a minimum of 24 hours. And then this is aimed to assist the tire industry thriving for the first time quality, and then we wish to provide an amicable solution to industry with alpha reliability. And the focus of the development was that we should give a solution to the industry in which only one test is there to qualify the rubber compound processing, then to qualify the cure properties of rubber compound, and the tire performance property indicator inside the laboratory. Say for example, the traction, the wet traction, one can have the predictor testing at 0 plus minus 10 degrees centigrade. For dry traction, it is at the uh, say 20 plus minus 10 degrees centigrade, and for rolling resistance it is the 60 plus minus 10 degrees centigrade. And a second focus of the development was liquid nitrogen free cooling. This ensures the safety of laboratory personnel, and uh, and the third focus was on the determination of real-time data based on actual shape factor that I already explained. The, we are using the thickness of the rubber sample at the test temperature. And last but not least, and the most important point, is to bridge the gap between shop floor mixed and R&D developed rubber compound data. So how this technology works is uh, we are having the compressed air supply from one end, and then there are some dryers, oil separators, then followed by the chilling unit, and the chilled air is being passed through the dies. So with the help of this, we can reduce the temperature of the RPA dies to negative 25 degrees centigrade, and it really significantly reduce the in-process testing time. And you can, and say this RPA SZ is your one and only say rheometer that eliminates the need for a DMA tester. And this is the one solution is all that you need, is to test the processability, cure characteristics, and tire performance, the laboratory indicator in a single test using the same rubber sample with lower capital spending. On the right hand side, you can see the two graphs. Blue one is from the DMA, while the green one is from RPA. And the 10 delta is higher. This is due to in DMA, in the tension compression mode, people are giving some static strain and then dynamic, while in RPA you can give only dynamic strain. So there are some difference of strain in the values, due to which the RPA 10 delta is higher, but it is higher consistent for almost all the rubber compounds that we have tested. And on the ground of specification, you can see the frequency is from 0016 to 50 hertz, then strain 0.07% to 1255%. Then the temperature is uh, the most critical thing, that is negative 25 to 230 degrees centigrade. And the maximum temperature ramp rate above room temperature is 1 degree centigrade per second, and maximum die cooling rate above room temperature is 0.5 degree centigrade per second. And you can see here the rate of sub-ambient cooling, means at what rate we are going from high temperature to negative 25 degrees centigrade, that is from 60 degrees centigrade to 30 degrees centigrade. We are reducing the temperature at a rate of minus 7.5 degrees centigrade, while from 30 degree to 0 degree we are cooling down the die at a rate of negative 5.5 degrees centigrade per minute, and from 0 to negative 25 degrees centigrade we are reducing the die temperature at a rate of negative 2.5 degrees centigrade per minute. So with the help of very controlled cooling rate, we are obtaining the the temperature stability at negative 25 degrees centigrade is plus or minus 0.2 degrees centigrade. And you can see the data reproducibility is less than 10% at sub-zero temperature, and the repeatability is less than 6% on stiff compound at negative 2.5 degrees centigrade. So our repeatability is really good, as well as the reproducibility is very good, excellent. Then the torque range is 0.01 to 225 deciliter meter, and the measured data is torque, temperature, frequency, strain, while all others are miscalculated data, that is the modulus component, the compliance component, the torque, the 10 delta, then the viscosity and the complex and the real and imaginary viscosity. And the data storage is SQL database. RPA, it meets the testing standard of ASTM D1053, D5289, D6048, D6204, D6601, D7050, D7605, and D8059. And now we will discuss on the PDM technology, that is for precision dynamic modulus determination. Means this technology is basically introduced into the Premier RPA plus to compensate for the sample shrinkage due to lowering of the temperature from the actual curing temperature of the rubber sample. So with the help of this technology, we are able to maintain a constant dye pressure, and we are actively controlling the pressure, and monitoring the change in thickness of the sample, and we are using the actual thickness of the sample at test temperature into modulus calculation. This basically helped us in improved accuracy. This helped us in the uh, improving the accuracy of rubber product of the rubber means properties, that leads to the safer products and the at a lower cost. Now you can see here for the cured SBR sample, the coefficient of variance has been reduced by 49%, while for uncured SBR on storage modulus, the coefficient of variation has been reduced by 81%. On the right hand side, that you can see here, the data accuracy and precision has improved, while the range of the specification is reduced to a large extent, while in the uh, storage modulus for cured SBR compound, again the span of the specification has reduced, while the accuracy and precision is being improved. So in the PDM technology, we are using the real shape factor. This gives us the most accurate rheological data in the world. Here is an example of the test data in which we conducted the test on Premier RPA and DMA. Only here the mode of deformation was a differ. In the RPA it is torsional shear, while in DMA it was tension compression, and the dynamic strain 5% in both, frequency again 10 Hz in the both instrument, while the temperature sweep from 35 to 60 degrees centigrade. Here only I wish to just explain you how the data correlates with the DMA. Now you can see the storage modulus, the R square is 0.9989, really good correlation is there from in the G prime to the E prime, while for the G double prime to E double prime, again good correlation is there. Then on the ground of 10 delta, if you can look at, the 10 delta is almost similar from both the instrument. And way forward for our the development of instrument is, we will definitely continue to strive for further improve our process, then product and its performance. And thank you very much for attending the rubber industry technical talk. Thank you very much once again. And if you have any questions, you can ask. I will be available till the end of this program. Or if you want to ask in person, you can send a mail to dilip.dhupi@alpha-technologies.com. Thank you very much.